In this video, we will discuss about the concept of the horse cart problem and the liftman problem. We are not doing numericals here in this video. We will solve it later. We are only discussing about the concept of horse cart problem and liftman problem. So first of all, for talking about the horse cart problem, there is a cart. This is a cart having the wheels and the mass of the cart is capital M. The mass of the cart is capital M, and this cart is connected by a horse. I am denoting the horse by a point only, and it is connected like this. So what will happen initially the horse will apply force by his legs on the ground in the inclined direction. So this will be the direction of force applied by the horse on the ground, that is F, capital F I am taking, and the weight of the force on this point will be in the downward direction, that will be capital W. And if the mass of horse is small m, then this capital W will be equal to mg. Now there will be one opposite direction force, or I can say action reaction force, in the opposite direction of the force applied by the horse, and it will be acting in this direction. This is the reaction force R, which is in just opposite to the force applied by the horse. If we want to make the components of this R, then I can make its two components. First component is in this direction, that is the horizontal component, and this one is the vertical component. Similarly, there is a force acting like the friction on the wheels of the cart, and it will be acting in the opposite direction. So on the cart there is a friction force, and I am denoting it by small f. And this is the rope, so tension will be applied, and for the cart tension will be applied in this direction. The cart will be pulled by this tension, and this rope will also pull the horse in the backward direction, so there will be tension here also. See, in these type of questions we always take tension in the both direction, and if there is only one rope, then only there will be the same tension T, only one tension is there. If there are two ropes, then we can apply two tensions. Fine. Now for when the horse will move forward if capital H is greater than capital T. So in that case, net force on horse will be equal to H minus T. And if the mass of horse is small m, then I can write it as H minus T is equals to small a. I am taking this as the equation first. Similarly, net force on cart will be given by, cart is moving in this direction, so capital T must be greater, hence capital T minus small f. This will be the net force on cart, and it will be equal to capital M into A. A will be the same acceleration as the horse is moving, as they both are connected, and mass is, capital M is the mass of cart only, so I can write it as T minus F is equals to MA. Now adding both of these equations, equation 1 and equation 2, T will be cancelled out, and we will get H minus small f is equals to M plus small m multiplied by A, or acceleration will be equal to H minus F upon capital M plus small m. So this is the acceleration produced by the horse when he is applying force, and this is also the acceleration by which the cart is moving in the direction of the force applied. The whole system will work only if H is greater than F. When H is greater than F, then A will be positive, and hence they will move forward. So the system will move only if H is greater than F, or there will be acceleration only if H is greater than F. So this is for the horse cart problem. Now for the liftman problem, there is a lift, and there is a man inside it. I am taking the whole mass of the lift and the man as small m. There will be the reaction force in the opposite direction R, and there will be the gravitational force mg in this direction. Now there will be few cases. In some cases the lift is moving upward, in some cases lift is moving downward, in some cases the motion is accelerated, or in some cases the motion is constant. So first of all, when lift is moving up, when lift is moving up with constant velocity, lift is moving up with constant velocity, when the velocity is constant and lift is moving up, then r will be greater than mg. So I can write it as r minus mg, and since there is no acceleration, so for ma I am writing it as 0. But when lift is moving with acceleration and lift is also moving upward, but it is moving with some acceleration, then I can write it as r minus mg, and it will be equal to ma. That is the acceleration of the lift, and m is the whole mass of the lift and the man. Now in the next case, when lift is moving down, when lift is moving down, so when lift is moving downwards, then what will happen? If lift is moving downward, r minus mg is equals to 0 for constant velocity, and if lift is moving downward with some acceleration, then I can write it as mg minus r will be equal to ma. In this situation mg will be greater because lift is moving downward. In the first case you can also write it as mg minus r is equals to 0. This one is also correct because lift is moving downward and mg will be equal to r. And this is also correct because in this situation r is equals to mg also. So best to prefer this one because lift is moving downward, so mg will be greater. So mg minus r will be equal to 0 when lift is moving with the constant velocity, and mg minus r will be equal to ma when lift is moving with some acceleration in the downward direction. So here r is also known as apparent weight of the man, and mg is known as actual weight of the man. Actual weight of the man. Okay. What happens when the rope of the lift breaks? When the rope of the lift is break, then there will be no r. So I can say r will be equal to 0 when there is no rope in the upward, or the rope is broken. Then apparent weight will be 0 and the person will feel weightlessness. Means he is falling freely, and he will feel that there is no weight in his body. In this situation, when the lift is moving up with some acceleration, what will be the apparent weight of the man from here? It will be equal to r is equals to ma plus g. Means it is more than mg. So I can say that when the lift is moving upward with some acceleration, the person will feel heavier because its apparent weight is increased, so he will feel heavier. But in this case, what will be r? What will be r here? R will be mg minus ma, means the apparent weight is reduced, so he will be feel lighter when the lift is moving downwards with some acceleration. So this is the concept for the horse cart problem and lift man problems.